Hello everyone, my name is Maurice La Fon. This is my term project presentation for Physics Lab of Harrisville State University Fall 2020 semester. I'll be answering the question of how do filters affect colors that we see, and I'll also be demonstrating how to use a stopwatch for those who possibly don't know. So we'll get started with answering the question, how do filters affect colors that we see? I already have the website pulled up here, and you may recognize it from one of our labs we did this year, Lab 8 Color. It is the colorado.edu lab, and it's very useful for showing how light passes through certain filters as we see here. So we have it set up neutrally. We have the bulb color yellow, we have the filter color yellow. What we want to do is we want to take either or the filter color or the bulb color. We'll do the bulb color because it's a little more lenient and a little more evident. We can see the color change. We want to take it from the yellow, slide it towards the violet, and you'll notice pretty quickly, as soon as we get to the green, you can't see any color. The person here can't see any color. And we can do the same thing, slide it to the red side. See a bit of orange there, and it turns to brown, and then it's already black right before we get to the red. And keep in mind, we're nowhere near the end of the spectrum. So from this, we can see the color changes pretty fast. Now, we started with yellow. We can also do this with a white and just change filter color. Notice how the white is almost completely universal. It can do every color. The person can see every color. But as soon as we go to the colored bulb, it's different. Now, this is evident in our daily lives, whether we notice it or not. If you were to take a yellow color and do it in front of a filter, odds are, depending on that filter, you want to be able to see the color itself. It would be blacked out or neutralized, and this is because the color from the source is so different from the filter or the lens that it's passing through that there is no color for us to see at all. You might just see a dim light if you're looking at the light head on. We usually don't see this in day-to-day life because the color or the light that we see from the sun is fairly neutral. There's not much tint to it at all, so we can see, your dark reds, your reds, all the way to your violets. It's very neutral. We take a yellow light, like this flashlight here, we're not able to see the color. So this answers the question, how do filters affect the color we see? And they don't really affect a neutral color that we see from day to day, besides changing the color itself. But if you're taking a filter from an already placed color, you'll see that it really cancels it out fairly quickly. So that's our first question, how do filters affect the color we see? And then we'll go ahead and go into a stopwatch. So I'm sure many of you are familiar with a stopwatch already. It's a handheld device. We can go to images here, we'll see right away. Your typical stopwatch will look something like this. But for today's demonstration, we'll just use this handy Google widget. A stopwatch is a handheld device that is meant to gauge the measure of time that occurs between initiation and the activation of a certain time period you're recording. You all know very well during this course, particularly during the earlier labs, we would time how long it would take a certain block to fall down a certain slope. Say your first child could be a 182, you go ahead and record that, do the same circumstances, the same block, the same slope, the same coefficient of friction, and we had a 182 that first time. Your second time might differ a bit, you might have a recorded 2 flat, even though we're using the online simulation, it's the same every time, but using the stopwatch demonstrates how we get a fixed number from several recordings, and it really narrows down our margin for error, and we construct an average for it. So that's all there is to a stopwatch electronically, that we might use on our computers or phones. But stopwatches used to look like this, not electronic at all. These were actually a bit more inaccurate, and we're talking fractions of a second. But in the world of science, when you're trying to find concrete evident findings, those fractions of a second are everything, really, because just one fraction off and your results are incorrect, and you can only discover that at a later time. So these were a bit more inaccurate. These are compound stopwatches compared to the electronic. Keep in mind, as you saw me do with the widget that Google does, I can't stop and start it every time the exact same. There is some margin of error for stopwatches, but there are different types of stopwatches. I know, being an athlete myself, you record athletic times and it's a sensor that starts and stops the stopwatch, so that's a bit more accurate. And there are also different ways to set up a particular motion or experiment that you could be doing that starts and stops a stopwatch. So altogether, the stopwatch is a tool that I'm sure all of you know and almost anyone knows how to use, but it's really handy because we can use stopwatch start and stop. We could see a period, something you're measuring is 0.55 seconds, instead of guessing in your head, oh, maybe that was half a second, maybe that was 3/4 of a second, or using a regular clock and not being able to see milliseconds, centiseconds, all that. So I hope this demonstration has been helpful, both filters of color and how it affects what we see and whatnot, what we can't see, neutral light compared to a different origin light. And of course the stopwatch demonstration, I imagine the filter demonstration was more informative and refreshing for the lab we did in week 8 compared to that of use of stopwatch, but nonetheless this is all good information to know going forward. So yeah, that is my demonstration of both how a filter affects the colors we see and the analysis and demonstration of a stopwatch. If you have any questions on either of these subjects, unfortunately the way this presentation is being made, I cannot answer any questions at this time due to this being a recording, but it's as simple as doing the lab, or maybe even doing the real life version of this lab. It's much more entertaining, so to say, than a just factual simulation, or you can go out and use a stopwatch on your own. But nonetheless, I thank you for your time, your patience, and yeah.